log in, but I don't see him. We'll get going without him here.
We'll just have to catch up.
So last week, we talked about all these trig functions. I want to make sure you remember how to calculate them. So we're going to use a calculator here. I want you to find the sine of 60 degrees, cosine of 20 degrees, and the tangent of 73 degrees. These were the big three. These are the functions that are right on your calculator. So we can just do sine of 60. We do sine 60. Now I'm going to make sure I'm in the right mode here. I am not. So I've got to go to degrees. That's something to always double check on your calculator. Most of your calculators, once you set them, they will stay, unless the batteries totally die, they will stay that way once you shut them off and turn them back on. Mine on here, of course, every time I shut it down, it resets to its setting. So sine of 60, I should be in degrees now. I get 0.8660. What you guys came up with? Cosine 20, same thing. Cosine 20. Technically, I don't have to close the parentheses. 0.9407. Or sorry, 0.9397. Can't round correctly. It is. Tangent of 73 degrees is 3.271, we'll call that. Now remember the restrictions on sine and cosine. It had to be between -1, +1, right? Can't have a sine or a cosine that's less than -1 or larger than +1. Tangent can be any number, from -infinity to +infinity. I have three other trig functions. One of them is actually a main function, the secant. I wanted to find the secant of 60 degrees. Which trig function, which one of our three main functions is linked to secant? This is the one that kind of is reversed logic. Linked to the cosine. It is the reciprocal of the cosine. And you could just type it in just like that, like I just showed it there. 1 divided by the cosine of 60. It will give you the correct answer, which is 2. But we found a shortcut for entering that last week. Cosine of 60, and once you close the parentheses, you use that x-1 key. Cosine 60 degrees, close the parentheses and hit the x-1, and it does give us that 2. That hitting that x-1 key at the end of the problem is the same as starting out the problem with 1 divided by. There's a reason I want you to use that key, because in a few minutes when we start reversing this process, using that key is much easier to do than trying to do the 1 divided by. So let's say we want to do the cosecant of 20 degrees. Cosecant is linked to what trig function? Sine. So it's the reciprocal of the sine. So again, I could do 1 divided by sine of 20. Or I could do sine of 20 degrees and -1. Come up with 0.924. Sound right? Now for secant and cosecant, since they are reciprocals of sine and cosine, their values, the absolute value of them has to be greater than 1. That means either it's smaller than -1 or larger than +1. They cannot be between -1 and 1. And of course, our last one is the cotangent. Let's do the cotangent of 50 degrees. Cotangent is linked to tangent. That's the one that actually does make sense, right? What is the reciprocal of the tangent of 50? Or again, we can use that reciprocal key. Tangent of 50, close the parentheses and do the x 1. That's 0.8391. And just like the tangent, the cotangent can be any value from -infinity to positive. What if I tell you sine of an angle, 0.7324? Well, last semester, we looked at solving equations, and this is just solving equations. I could put an x in there instead of an a. Typically don't use x, y, and z for missing angles. We either use Greek letters, theta, alpha, beta, whatever, or we use capital A, B, C letters for those angles. But this is no different than having something like 3x equals 21. Solve that by using an inverse operation. This was created by multiplying by 3. The inverse of multiplying was dividing. So the inverse of multiplying by 3 was dividing by 3. X equals 7. Well, we have to do the same thing here. To find a, we have to do the inverse of sine. What's happened to a is we've taken the sine of it. The inverse of it is an inverse sine. There are 3 different notations used for the inverse of a trig function. More specifically right now, the inverse sine. We can do inv sine, inverse sine. Or we talked about the arc of that unit circle being the length of the value of the angle. So we go back to finding the length of the arc. The angle actually in radians instead of degrees, but it's the thing. Or the more common modern notation is just this. Sine with a little -1 after it. Now that looks a lot like the x -1 key we've been using. It does not mean the same thing. It's an inverse sine, not a reciprocal of a sine. So this is not a cosecant. It is reversing the sine. So there's a little bit of confusing notation here. So what we have to do here is we have to do that inverse sine of both sides of that equation. Now on the left side, the sine and the inverse sine just cancel out and we're left with angle A. On the right side, to get our calculator to do an inverse sine, we use either the second or the shift key, depending on your calculator. Second and then sine, and you'll notice it gives you, instead of sine, it has sine -1 there. In the parentheses, you put the 0.734. Close the parentheses, and it gives us 47.09 degrees. It is customary. We said that our trig functions themselves get rounded to 4 place values, whether it's 4 decimal places, or if there's a digit, a non-zero digit in front, we go to 3 decimal places. Angles, it's traditional to round to 2 decimal places. If I tell you the cosine of angle B is 0.1153, solve that, I'm going to do inverse cosine. So again, on the left side, the inverse cosine and the cosine cancel out. Right side, to do inverse cosine at second cosine, 0.1153. Parentheses, 83.38 degrees. If I tell you that the tangent of angle C is 4.62, what do you think we're going to do with that? Inverse tangent. So again, on the left side, the inverse tangent and the tangent cancel out. We get angle C equals second tangent 4.62, 77.79 degrees. I'm going to have you solve these over here. I want to give you a few. Sine of D is 0.419. Cosine of E is 1.032. Tangent of F is 0.0181. Solve those for those missing angles D, E, and F. Where you guys punch it in like 8 times. I'm not a very nice person. What's wrong with that second one?
Very big one.
Yeah, the cosine can never be larger than 1. So no matter how many times you punch it in, the inverse cosine of 1.032 is going to be error no matter what you do. So if you punch that in like 3 times and it still comes up an error, yeah, I'm not very nice. I'll give you a second to finish up the last one if you still. So for sine of D equals 0.419, second sine, 0.419, and we get 24.77 degrees. Everybody concur on that one? And for the tangent of F equals 0.0181, we get inverse tangent, 0.0181, we get 1.04 degrees. Very small angle. Let's talk a little bit more about inverting something. And the parallel I like to draw here is equation still. I have 3x plus 7 equals 19. Remember, when this was built, what was done to x was multiplied by 3 and then 7 was added to it. When we go to take it apart, what do? Go backwards. The last piece put on is the first piece off. We subtract 7 first. X equals 12. Then we divide by the 3. Do reverse order and the opposite operation. Adding 7 was the last thing done. That's the first thing we removed. We did it by subtracting 7. So when I look at something like of 20 degrees, the way I find that cosine of 20 degrees, and then I did the x negative 1 outside. Now, first of all, what is the inverse of x negative 1? A reciprocal is its own inverse. If I take the reciprocal of 2/3, that would be 3/2. The reciprocal of 3/2 would be 2/3. It goes back to itself. So it's its own inverse. So if I am given something like secant of angle A, 2.437, I would have calculated that by doing cosine of A and then x negative 1. To go the other direction, of course, I start with the 2.437. The last thing that was done over here, the x negative 1. That's got to be the first thing done here. And then we do the inverse of the cosine, which is the inverse cosine. The way I wrote it out there is exactly how it has to be entered in our calculator. We still have to do the second cosine first when we punch in the keys. But notice we do 2.437. Before I close the parentheses, I do the x negative 1. Let's say that x negative 1 happens first, then I do the inverse cosine. Gives me 65.77 degrees. That is why I use that x negative 1 key instead of doing 1 divided by cosine, is because it's a lot easier to use that key as we're going the other direction. We could have done inverse cosine of 1 divided by 2.437. Give us the exact same answer. Second cosine, 1 divided by 2.437. It's the same answer. It's just kind of tedious to have to remember to do that 1 divided by first. So, if I tell you that the cosecant of angle B, 7.34, E is going to be inverse sine 7.34, and then the x negative 1 inside the parentheses. .83 degrees. If I tell you that the cotangent of D is 0.6461, of course, D is going to be the inverse tangent of 0.6461 with the, again, the reciprocal key, the x negative 1 inside the parentheses. .13 degrees. Let me try a couple of these. If I tell you the cosecant of angle F, 3.5, cosecant of angle G, 1.88. And the cotangent of angle H, 0.7743. Find F, G, and H for me. So for F, cosecant, of course, goes with the sine, so it's the inverse sine. 3.5, do the reciprocal inside the parentheses, 16.60 degrees. For G, secant goes with cosine. For cosine of 1.88, again, reciprocal inside the parentheses. 57.87 degrees. And finally, cotangent of H, tangent goes with cotangent. So it's second tangent of 0.7743. Again, reciprocal inside the parentheses, 52.25 degrees. These are not fun by any means. You gotta do two things. You gotta remember which main function goes with it. The cosecant goes with sine, secant with cosine. Again, the easy one to remember, of course, cotangent going with tangent. And then you've got to remember what order to put them in. When you're going inverse, that reciprocal key, that x negative 1 goes inside the parentheses. So far, we have only looked at angles between 0 and 90 degrees. The main reason is because we're going to start, actually starting tomorrow, we're going to look at finding missing pieces of a triangle. In a right triangle, there's a right angle in one of the angles. The other two angles both have to be smaller than 90 degrees, because the angle sum is 180 degrees. One angle's 90, that only leaves 90 degrees left for the other two angles. So they both have to be smaller than 90. They can't be 0 degrees, so they both have to be smaller than 90. That means we've only been dealing with trig functions in this portion of our unit circle. But let's talk briefly about some corresponding angles. This is 30 degrees, a 30-degree angle. Now it is a 30-degree angle, but it also has what's called a reference angle. Its reference angle is also 30 degrees. The reference angle, remember we said this was referred to as the terminal side, remember? That was where if we started at 0, right here, and we rotated around counterclockwise, that's where we would end after rotating that degrees. The reference angle is the angle between the terminal side and the reference axis. Reference diameter. That horizontal diameter, remember we said, was our main reference diameter. The vertical one was our complementary reference diameter. If I go around here to 150 degrees, what's its reference angle here? $30. So 150 degree angle has a 30 degree reference. Well, what do we know about those? Or what's the significance of that being the same, I should say? Well, the sine of 30 degrees here, if I type it in, sine of 30 is going to be 0.5. Right? What's the sine of 150 degrees over here going to be? Well, if I type it in, sine of 150, it's also 0.5. And it makes sense. The angle with the horizontal axis is the same, and the horizontal diameter is the same. Radius is still 1 unit, so the hypotenuse is the same. That opposite side has to be the same. So those two angles have the same reference angle. They have the same sine. When we do an inverse sine, if I tell you that sine A equals 0.5, we type that in the calculator as an inverse sine. The calculator just tells us 30 degrees because the calculator is going to tell us what's called the simplest solution to that. But there are actually infinitely many angles that have a sine of 30 degrees. I could start here and I could wrap around to 390 degrees. That's going to have a sine of 30 degrees because it's going to be, terminal side is going to be right there. 390 degrees is the same as 30 degrees. It's just got a full turn before it stops. We're not worried about those. We're sticking between 0 and 360 here. Actually, it might dip back into negative 90 degrees because sometimes people find it easier. 90 degrees rather than 270 degrees. Still, we're staying in the main rotation of the unit circle. We're not worried about those over 360. But here we can see 150 degrees could also be the inverse sine of 0.5. Well, for what we're going to do for the next week or so, when we're dealing with right triangles, that doesn't matter because our angle must be between 0 and 90. Can't be bigger than 90 degrees. But at some point, we are going to look at what's called oblique triangles. Don't have a right angle, so it is possible to have an obtuse angle in them. So we need to be aware of that possibility. Now, there are two other angles in the main rotation of this circle that have a 30-degree reference. Right here, 30 degrees. What would this overall angle be? Well, this would be 180, right? Yeah. 180 plus another 30 would be 2. Another one over here that's 30 degrees. That's 30 degrees. This overall angle all the way around there is 30. 360 minus 30 gives. The sines there will still relate. This sine is still 0.5, but it's actually a negative 0.5 because it's below the axis. Same here. Negative 0.5 because it's below the axis. If I do an inverse sine, or negative 0.5, rather than 30 degrees, the calculator will actually tell me negative 30 degrees. Considers that simpler than saying 330 degrees. But if I do the sine of 330 degrees, it still gives me negative 0.5. Cosine actually is slightly simpler. I have 30 degrees here, this is the sine. The cosine is actually this distance, right? 0.866. I go over here where there's a reference angle of 30 degrees. Once again, that's an overall angle of 150 degrees. That cosine is a negative 0.866. Where would we end up with the same cosine? Oh, it would actually be over here at 330 degrees, or a negative 30 degrees. Calculator usually. So cosine of 30 is 0.866. Cosine of negative 30 is also positive 0.866. So if you have the same reference angle, either the sine, cosine, and tangent, the trig functions will either be the same or they'll be the opposite. They'll be the same number, but negative or positive. Which brings us back to our secant and cosecant. For the cosine here, by the way, it doesn't matter quite so much because we don't want a negative angle generally. A triangle can't have a 300 plus degree angle in it. So we're only worried about these two quadrants when we're dealing with triangles. So the cosine, when we're doing inverse cosine, it's not a big deal because this is 30 degrees is the only positive angle between 0 and 180 that has the inverse cosine of 0.866. This would be a negative 0.866. So for cosine, they're distinguishable. It's sine that's the issue. For sine, there are two angles between 0 and 180 that have the same sign. So we have to be aware, is it an acute angle or is it an obtuse angle? We're doing that inverse sine. Sine then, of course, affects the cosecant. So the cosecant is affected the same way. If I ask you for the cosecant of angle A, 0.4, and I want to find angle A, well, A is going to be the inverse sine 2.4 with that reciprocal inside the parentheses again. Second sine 2.4, x negative 1. I get 24.62 degrees. The other option would be its supplement. 180 minus 24.6, or 155.38 degrees. So if I tell you that the sine of angle D is 0.7032, but I also tell you that D is obtuse. How do I find angle D? Inverse sine of 0.7032 give me 44.68 degrees. How do I find the obtuse equivalent to that? 180 minus the 44.6. So it's 133.32 degrees. The obtuse angle that has the same sign. So it's the inverse sine that we're most concerned with. Inverse sine, it's either going to be that angle or it's going to be the supplement of the angle. Like I said, for the next week or so, we're going to be dealing with right triangles. It's always going to be just what the calculator gives us. Right triangles, we have to worry about that second possibility. In the packet I gave you, I believe page 341 and 342 is in that packet. Somebody would check for me just to make sure. And page 345, 347 is in there as well. Having to do the odds on, for 341 to 342, it's 75 through 121, the odd. 345 to 347, just do the odd.